All right, everyone, let's get settled. I'd like to start first congratulating all the engineering students for finishing the final assignment. I know this program is crazy tough. I don't know how your brains aren't melted to the floor at this point, but yeah, they are melted. Okay, so then. But you know, the truth is, even though we don't have any more assignments for this academy, I think this is really where some of the most exciting learning begins, right? Like, I mean, we're finally talking about this thing that you've never heard of before, Polkadot, right? And so we'll hopefully be able to explain that to you, give you an insight into you know, how all of the things we've learned so far build up to this larger idea, right? And then even some of the cool things that Polkadot can provide, like XCM and interoperability and stuff, right? So I really think that even though the assignments are over, the learning is still just beginning, right? Right. I think I'm very privileged to be able to give you the introduction to Polkadot. I think that there are many ways you can do an intro. I think that if you asked pretty much anyone in Parity or in the Polkadot ecosystem to give them their intro to Polkadot, it would be a little bit different. In some ways, that's exciting. I think, from my perspective, when I think about Polkadot, I think about a evolving modular system, right? And so to describe what it is today, I think would not actually be a great introduction to Polkadot. I could tell you exactly, you know, all the features it has, all the buttons you can click, all of the exact mechanisms that happen, but that is not, in my opinion, actually a description of Polkadot. It's a description of the relay chain or a description of the code base that is as it is today. What instead I want to do is I want to talk to you about the decisions of Polkadot, a set of philosophies, visions, goals, which actually describe the mission that we're trying to build. And then I want you to understand that the product that we created is our best bet at that mission today. And that as time evolves, as technology evolves, as our learning and ability to do stuff evolves, that technology itself may evolve. But ideally, I think that the decisions and philosophies of Polkadot will stay pretty true and steadfast for the future. So that's going to be my approach on talking about the introduction to Polkadot. Obviously, over the next all of the lectures, if you're in the engineering side or if you're on the founder side, you're going to be hearing more tangible, concrete stuff. But I think this is my perspective on that. Cool. I guess one last thing, you know, we just finished the frame area. I'm not sure if they've asked you already to give feedback, but you know, we really care for and appreciate the feedback. You know, I will look at this stuff to see how we can continue to improve the frame lectures, improve the exam, improve your learning. I've already heard some feedback one-on-one, you know, from students, you know, who finish their exam projects or just have ideas. But really, when you know, as soon as you tell me, it's like, oh yeah, that's a great idea, and then you know, my brain is fried as well from grading and all that kind of stuff. So please write it down. Please, you know, really give your honest feedback. It doesn't hurt any feelings if there's something that didn't go well. It does feel great when you acknowledge things that did go well. So feedback is important. We actually learn and really recognize that. So please do that as well. Anything else I missed? Any quick comments or before we get started? Okay, who's excited about Polkadot? Okay, if your hand isn't up, shame. Okay, okay. So anyway, the decisions of Polkadot. This presentation will try to explain the core decisions which define the Polkadot network. Again, I'm not here to explain to you Polkadot does this, this, and this. I want to really go at a higher level, a more meta level, at what we're trying to build, what we're trying to accomplish. I want to start by talking about an invention machine. So Jeff Bezos outlined in an annual letter to Amazon shareholders how he approaches decision making by categorizing decisions into type 1 or type 2 decisions. Type 1 decisions, I'm going to read this out loud. Some decisions are consequential and irreversible, or nearly irreversible, one-way doors. And these decisions must be made methodically, carefully, slowly, and with great deliberation and consultation. If you walk through and don't like what you see on the other side, you can't get back to where you were before. We call these type 1 decisions. And on the other side, we have type 2 decisions. But most decisions aren't like that. They are changeable, reversible. They are two-way doors. If you made a suboptimal type 2 decision, you don't have to live with the consequences for that long. You can reopen the door and go back through. Type 2 decisions can and should be made quickly and by high judgment individuals or small groups. And I really want to frame this in the context of blockchains. I think that this idea of type 1, type 2 decisions is the way you can unlock your brain from actually making progress. You know, there are a lot of protocols out there or people out there who are unable to actually take a step forward because they're concerned with every step they take. I think it's really important that you need to identify, is the step you're taking forward a type 1 or type 2 decision? So in the context of blockchains, Type 1 decisions. Decisions that cannot be easily changed in the future. They must be part of the original protocol design. Changes might as well be considered a new protocol, right? And then type 2 decisions, changes that can be easily changed in the future. They can be included at a protocol at a later time. They can be considered as part of the evolution of the protocol. So without naming names, I think we can be very honest that there are many protocols out there, many blockchains out there, which their future or V2 vision is not in alignment at all with what they built in the past. It's not an evolution of the protocol, it's a change of the protocol. Pretty much the only thing that stays the same between two parts or two different versions of a protocol is the token name and the protocol name. But underlying technology is not the same at all, right? And this becomes very tough. This is a signal that a protocol has not thought ahead about what they want to build, right? Instead, I really want to focus on how we can, as often as we can, make the correct type 1 decisions, the core fundamental parts of our protocol, and then see how we can set it up to allow for type 2 decisions, for fast iteration, okay? So, before we can even talk about making decisions, we must first align ourselves with the philosophies. What are our visions and goals in which the decisions will align to, right? So what are the philosophies of Polkadot? I think the first is one that maybe you've heard before, or hopefully many times, and many times in the future: less trust and more truth. I think the ultimate belief is that we need blockchains in our world because in the situations where we have relied on central trust, we have been taken advantage of. That in fact, systems are much better for societies and people and everyone when you can yourself verify the truth of situations, right? You don't have to trust on others to do right. Now, for many people in the world, the actual truth is that trust works fine for them, right? If you were to go around and actually ask most people, are there problems in the world from your perspective? Are there problems with the financial system in your perspective? Many would say no. I mean, if you're in this room, it's likely that you're, maybe from the first world, that you have good banking systems, that you have access to funds, you've been able to use credit cards, etc. But this is not true for everyone, right? So I don't think necessarily it's true that everyone relates with this philosophy. But I think that if you can take a step back and realize and look at all the places where we have relied on trust and we have been taken advantage of because of that, or people have exploited that trust, then you realize that there is room for systems with more truth, right? I want to mention one last thing. It doesn't say on this screen, no trust, all truth. It's less trust, more truth. A lot of the engineers and maybe even the founders are realizing, you can build systems integrating blockchain, but you can't necessarily eliminate all aspects of human, right? All aspects of involving a society or community. So when we're trying to design technologies, blockchain is a great foundation for a truth machine, right? But in many ways, you need to figure out, and the clever engineering aspects of actually building blockchains is integrating trust into the machine without compromising on truth, right? You need to find some kind of middle ground, some kind of systems, right? And so if I think in my head like things like oracles, things like identity providers, reputation, these are all the most kind of clever engineering problems in this space because it relies on somehow, carefully navigating truth and trust. Okay? So this is one philosophy. The next, a bet against blockchain maximalism. And I think that this is becoming more and more the common narrative today. But 5 years ago, 6 years ago, when Polkadot was being first created, this was actually a very radical idea. You are talking about a time where basically you were either a Bitcoin maxi or an ETH maxi, right? There was basically two chains and one was going to win. And I think the entire blockchain ecosystem unfortunately has a curse, the curse of maximalism, because as soon as you purchase one chain's token, you are now economically invested in that chain's success. Your brain shuts off from saying, let's solve the problems of the world, and instead say, let's solve the problems of this chain so that we can make this price go up. But in fact, this is not actually the right mindset for creating and solving problems that we actually want to solve with the world, right? That actually getting to less trust and more truth. What we actually want is we want to support an ecosystem of many blockchains. Our belief is that no single chain will solve all the problems that we want to solve in this space. And instead, what we really should rely on is a set of chains that are optimized for different single applications, different purposes, different communities, etc. Now, there can be chains which are more, overreaching, that touches more people, but there could also be chains which are touching more smaller communities, right? And so I guess, the narrative nowadays is this application-specific chain, but we've been doing it for a while, and that's been a core part of our philosophy. We believe that the future will have many chains. And I think Polkadot, if you look at it, is a bet on that. The last philosophy. The best blockchain today will not be the best blockchain tomorrow. And this is really hard because we are building systems which are inherently living forever, if that makes sense. A blockchain is almost like an organism, right? It grows, it builds block, it breathes, it involves the outside world to continue letting it grow and live, right? We're almost feeding it when we give it new blocks. But the realization is that, blockchain is only 15 years old today, right? The amount of technological improvements we've seen in this space has been astronomical, right? Even in the last just 5 years, right, we've seen huge, rapid growth and exploration. I think we'll continue to see that for many, many years to come. If you talk to people who are building these kind of blockchain systems, I think they would want to tell you that their blockchain will be there not only 10 years from now, 20, but 100, maybe 1,000 years, still running, still providing good resources to the community. And if that's the case, we need to make the realization that the technology and decisions that we make today may not directly apply to the needs of the community tomorrow, right? That even if we build the perfect financial system with a blockchain, the perfect reputation system or identity system with the blockchain today, that a society a couple of years from now, there would be 5, 10, 100, will have different needs and requirements. And therefore, if you want to keep your blockchain, your system, your organism relevant for that time, it must be able to evolve and adapt quickly, right? So really, these really 3 core beliefs, I think, come together into many of the decisions of Polkadot, and I hope that these resonate with you as a starting point. Okay. So then, now that we have an aligned philosophy, what we're actually aiming for, let's talk about the goals of Polkadot, right? Who's seen this triangle before? Yeah, most. I think this is the problem we're all trying to solve in the space. All blockchain, the speculation on blockchain is pretty much on the speculation of who can solve the scalability trilemma, right? And this basically says there's a difficulty in trying to create scalable, decentralized, and secure systems. In that if you want to scale up one of these, often you need to make compromises on the other 2. Or if you select 2 of them, you make compromises on the 3rd, right? And this is a challenge. So security is about how much does it cost to attack the network. Scalability is how much work can the network do. Decentralization, how decentralized is the network itself, right? And you can imagine that you can create a very secure and scalable blockchain, but usually you give up on decentralization. You can have one centralized node or a few and have them run very fast and very secure within the context of their own system. You can imagine also tweaking any of these things. So we are ultimately, with Polkadot, trying to solve this scalability trilemma, much like many other protocols. But we are trying to do so without compromising on our philosophies, right? On our philosophies of less trust, more truth. It is not good enough to just create this scalable hyper protocol that's not decentralized. That does not align with the philosophies of Polkadot, right? So how can we, at best as possible, with the technology we have today, satisfy these 3 points? So in one sentence, what is Polkadot's mission? Polkadot's mission is to provide secure, scalable, and resilient infrastructure for Web3 application and services. Now note, in that triangle, there was secure, scalable, decentralized. This is a point I want to make. I use the word here resilient. I want to clarify that one of the misconceptions that happen in this space is that decentralization is the goal. Decentralization is not the goal. Decentralization is a single utility that can help you make a resilient software, right? So in this context, why do we want more nodes running a blockchain? So that it has less single sources of failure. Like if a government wanted to come and shut it down, that it couldn't. If you have a 10-node blockchain, it is not decentralized enough to be resilient. If you have 1,000 node, you're getting better. 10,000 node, I think you're pretty much there. 100,000, have you actually, relatively speaking, increased the resilience of your protocol equal to the amount that you've scaled the decentralization? I think the answer is no. There's what is the word I'm looking for? The plateau. There's a plateau at some point where you are you're decentralizing so much where the resiliency doesn't increase. But as you know from an engineering perspective, that there are true costs to decentralization. right? That if you have a network with 100,000 nodes, or in general, nodes network scaling scales as n squared. That's a kind of a high-level perspective. So when you go from 10,000 to 100,000, you may be increasing your resiliency by, let's say, 2x, but you're increasing your scalability problem by, 90,000 times 90,000, like some huge number, right? So again, I wanted to make sure that our mission is to provide secure, scalable, resilient. It's not the goal to just increase this number of nodes or validators to infinity. It's to find where we can be as resilient as possible while scaling our protocol as well. So this, again, is a common misconception. Decentralization is not the goal. It is not itself the metric you want to look at. Resiliency is, okay? Okay. So Polkadot tries to accomplish this mission by solving 3 problems: computational scalability, shared security, and interoperability. And we'll be learning about all these topics, I think, throughout the week. I'll touch on some of them, but these are the main core ideas. And so when you're thinking about what are we learning, or what are we, what is Polkadot innovating on, it's these 3 points. Okay, now that we've seen the goal of Polkadot, we've seen the philosophy of Polkadot, now we are able to make decisions, right, that are in alignment with those goals and philosophies. Okay? So what are the type 1 decisions that we make in Polkadot? The things that are hard to reverse, the things that define our protocol, and that we need to, basically the foundation on which we build other type 2 decisions, right? The first is WASM. And, truthfully, this slide itself may evolve actually in the very near future. Who here has been hearing about the Polka VM, the RISC-V stuff, right? So in many ways, the evolution of this slide is actually the decision of Polkadot is to use some kind of shared open VM environments. But in this context, let's talk about WASM, because that's what we exist today, right? WebAssembly is the backbone of Polkadot. It is fast, a safe, secure, open meta protocol which powers all of the state transitions in our ecosystem. And you probably have heard about WASM multiple times throughout this, this academy. But I think that the importance of WASM is kind of almost, it's still understated. I mean, we can say the word in every presentation, it's still not as well understood how important this is. I think later today I'll have a presentation on what is shared security, and I'll try to show you exactly how we use WASM. But the idea is that basically, if we can standardize how chains execute in this multi-chain environment, and sandbox that execution for improved security, we can allow teams to build these reusable protocols which can be interchanged, modular, and shared across the ecosystem. One of the problems we have in this multi-chain future is that everyone wants to build on their own stack, and that makes many, many technical challenges very hard. If we can kind of agree at a high level about a shared, open meta protocol, we will solve many of the problems in the future of a multi-chain future. So WASM is, I think, very much a type 1 decision, but I think at an even higher level, it's the search for a meta protocol. So RISC-V might be that meta protocol, if research shows that it's better. Okay? The next is sharding. I think it's, people, always, not always ask, but I guess if the question in everyone's mind is, how does Polkadot scale? Or what is the scaling thing? It's pretty simple. We use sharding. We use execution and data sharding through parallelization. These things called parachains. We parallelize the execution and we separate out data into these things called parachains, and these are basically shards of a network. We've created a sharded ecosystem. Okay? I think it's pretty straightforward. How does Polkadot scale? We parallelize our stuff. We're not building a single fast chain. We're building a parallelized chain. And an additional decision we made on top of parallelization is the choice not to create homogeneous shards, but heterogeneous shards. This means shards of different types. So if you remember back in the original ETH2 vision, ETH2 was basically sharding, but homogeneous. Every single shard would be a EVM chain. We decided that this is not actually the path towards a multi-chain future, that having a bunch of the exact same chain doesn't actually give you advantages out in the real world. Instead, application-specific chains can allow you to customize your cryptography, your database structure, your applications itself, what features it has, everything you need can be optimized for your application. For all of you, again, who just finished studying Substrate, you can realize how modular and extensible your ability to create your own blockchain is. That is, again, coming directly from the idea that we want to create application-specific chains, and that application-specific chains are going to be better for solving the problems of the future. Okay? And then, if we have a bunch of application-specific chains, right, that means that by nature, they don't have full feature functionality. You're not going to be able to do everything on one chain. You actually need to interoperate, interact with different chains, right? So in order for you to have a cohesive ecosystem, a multi-chain ecosystem, where every chain has their unique feature and their specialization, in order for that to be a part of a cohesive future, you need to have them be able to interoperate and communicate with one another. So ensuring that Polkadot has built into the root core the ability to support multiple chains through sharding and how we scale, that all these chains can be different, that we can actually communicate and interoperate within these chains. These are all the core decisions of what we're trying to build with the Polkadot protocol, okay? And what you can see here is that, we have, of course, support at the Polkadot level of support of XCMP channels. We'll learn a little bit more of that, obviously, all in the last week with XCM. Addition to this, okay, we now have a bunch of application-specific chains in the multi-chain world. They're talking to each other. But are they secure? One of the most commonly overlooked problems, and the thing that I'll talk about later today, is the scaling of security, right? So we can, of course, scale the technology aspect, scale the number of transactions, etc., through sharding. But are all of these different shards going to be secure? And if they aren't secure, have we created a product which is actually in alignment with our philosophies, with our decisions, right? So the answer is we need to create also, in addition to this technical transaction scaling problem, a security scaling problem. And Polkadot is unique in the fact that it provides, and has always provided, shared security for all parachains. Every single parachain connected to Polkadot has the same level of security as the Polkadot network itself. This is unlike many other multi-chain ecosystems which do not provide shared security. And you'll find that some of them out there are scrambling to figure out how to do this, because they thought about this after the fact. This was our type 1 decision. This was in the original Polkadot white paper, right? These kinds of decisions come and are integrated into our technology stack. And it is hard to build these things after the fact. That's my point about type 1 decisions. That type 1 decisions, you need to make them early on in the protocol. That when you try to scramble at the end to figure out how to do this stuff out, you're basically either changing the whole protocol itself or you're making compromises, lots and lots of compromises, right? So it's important that we have always had in mind the idea of scaling to the multi-chain future and providing security to all of them. And of course, I'll talk about this more in the What is Shared Security presentation later today. Now, our shared security system is powered actually not at the parachain level, but through the level of execution cores. Now, this is kind of a newer narrative coming out, right? I would say that it's hard to actually make present slides on this stuff. There will be some slides, obviously, throughout the whole week, but it's hard because this is very much an idea being formed. But I'll tell you this, at the code level, we never actually programmed in this, we are securing this parachain. In fact, what we've always said is there's an application, this parachain idea, like a WASM blob, and it receives an execution core. It receives some core on this kind of like ubiquitous computer to run on. And our shared security lives at that core level. And so I think as the evolving narrative of like Polkadot 2.0 is happening right now, we are seeing us break down from this kind of encapsulated idea of like this is a whole application blockchain system to actually showing you what is actually there, these execution cores. And this transition from Polkadot 1 to Polkadot 2 will not be a transition of type 1 decisions. It will be just a transition of type 2 decisions, because from the beginning, these execution cores have always existed. And so all the flexibility and belief that you will see from like this Polkadot 2.0 vision is coming from, again, type 1 decisions we've made from the beginning. So the execution cores provide block space as a service, and they're designed to work with any kind of consensus system. So this is very much kind of what's happening in the background, in the parachain level, in the shared security level. So an interesting key result of shared security through the relay chain is that not only does it keep all of the chains secure, but it keeps interactions between chains secure as well. This means that blocks which are finalized on Polkadot imply finalization of all the interactions between chains as well. So again, we are seeing a world where the multi-chain futures become more and more obvious, and there are all these blockchains who had the type 1 decision that we're going to be our own chain. We have no concept of other blockchains, and now they're suddenly bridging to each other. There's all these bridges and bridge protocols, and it can range anywhere from the very trustless bridges that we're creating here in Polkadot with things like Beefy, to the very trustful bridges, which have like a 3 or 5 multisig, basically depending the whole ecosystem between 2 blockchains. And when we think about 2 different blockchains with their own security interacting with each other, what we really need to think about is how secure is that bridge? How secure is the securest of the 2 chains? So with Polkadot, we're able to actually bring security into the interaction layer of the parachains themselves. So it not only secures the individual chains, but the interactions between them too. And this idea of being able to secure interactions is also still evolving. The type 1 decision is there. But the type 2 decision on how exactly we do it and what are the primitives that we provide, things like spree or accords, you might have seen some talks about this, are still in the pipeline. Hybrid consensus. So another type 1 decision, which has allowed us to scale Polkadot very well, is the ability to separate consensus systems. So we have a separate block production pipeline and a separate finality pipeline. Okay? Now many blockchains, they actually combine these 2 together. Right? And that makes it for a more simple system. But a more scalable system is actually one where we split the 2, where we allow, for example, chains to be able to produce blocks and let finality potentially lag, but then resolve itself quickly at the end. The idea here is all about uptime. So when we think about designing our multi-chain future and our ability to provide resilient systems, we want to have a system which, in the case of attacks or network fragmentation, the blockchain doesn't suddenly halt. There are terms like instant finality that you hear from certain protocols. That sounds really nice, right? Instant finality. It's instant. But what compromises are they making to make it instant? They're basically saying that if they cannot come to finalization, if there was some kind of consensus issue, the blockchain halts. Because instant finality requires that that block must be finalized before you can make the next one. You have now created a system which sounds sexy, which maybe has a slightly faster finalization time, but has the ability to halt or not be resilient under real-life attacks. This split of block production and finality means that, yes, Polkadot could lag in finality. And we've seen in the history of Kusama some lagging happening. But at the end of the day is that we are able to continue to produce blocks. We are able to, because of that, be able to do upgrades and other kind of fixes to the network and the system, keep it resilient, and again, allow finality to act after the fact. This is in mind for a resilient future. Do not take memes like instant finality by their name. To think about the decisions they're making about, when they choose protocols like that, right? Let's wait until I get to the end of this, and then we'll take questions, okay? Because what I worry is that it's very easy to just start a question. It just opens, okay? But write your question down so you don't forget, please. Okay, a light client first mentality. So this is actually one of those things I think hasn't actually picked up in the ecosystem as much as it should. But light clients are a super important part of the Web3 future, right? It is not going to be that every one of you are going to be running a full blockchain node back at home that you're accessing to be able to interact with. And we don't want that in order for you to interact with a blockchain that you need to connect to Infura or some other centralized provider to actually access the blockchain. How can we have you use your mobile phone, access a trustless blockchain, and have that interaction be trustless too, right? We need light clients. And for light clients, we need to build technologies which support light clients at the blockchain infrastructure level, right? That if we wanted to make a faster system, we wouldn't need Merkle trees, we wouldn't do that. We'd have other forms of data accumulation, we have other forms to be able to support consensus. But the Merkle tree is a key part of creating Merkle proofs, which is a very lightweight way of providing data to things like light clients. That we put all of the extra work onto things like the full node so that light clients can exist, right? And we have built Polkadot and Substrate with light client features in mind since the beginning. Even today, right now, we have full light client support. You can, without downloading anything, go to a website, download a WASM version of the Substrate client, the Polkadot client. That will download a WASM runtime for Polkadot or any parachain, and will run the entire parachain as a light client on your browser without downloading anything. Again, going back to WASM, the decisions of WASM, that this is part of the future of what we believe Web3 to be. That we are able to access these kinds of general execution environments from things like your browser, from things like your mobile phone, right? So light client support has always been super important. And even though it makes some things harder to scale, we do not want to give up scalability and sacrifice things like light client. A scalable protocol does nothing to our world if we can't provide that access to that protocol in a trustless way. Does that make sense? On-chain runtimes and forkless upgrades. So I think everyone had learned in the Substrate slides that we have this separation between the client and the runtime. And we had this very kind of clever choice of putting the WASM runtime, this general, again, execution logic for your blockchain, into the database of your blockchain. That means that I can actually use on-chain governance to decide what logic is of my blockchain and push that upgrade to all the nodes on the network. This aligns with our ability of evolution, right? The best blockchain today is not the best blockchain tomorrow. How can we optimize our blockchain to evolve and change over time? Well, the on-chain runtime and forkless upgrades is absolutely in that light. And I would argue that even if Polkadot is not the best blockchain today, if you can agree it is the most evolutionary blockchain, it is the blockchain best equipped to evolve and change over time, that it's just a matter of time before it becomes the blockchain that is able to evolve and be resilient against all of the changes you're seeing in the world, right? All of the new laws, all of the new requirements, governments that are trying to attack these chains. If you do not have an evolutionary protocol, it will die. They will find a way to squash that protocol. That designing an evolutionary protocol is very important to making sure it stays alive and relevant for our society. And so the ability of having on-chain runtimes and the forkless upgrades is the key aspect into making sure that Substrate and Polkadot will maintain relevance in our future. And on-chain governance, right? We described right there a technology for how a blockchain can evolve. Now we need to define a method for which the evolution decisions will be made, right? Now, if you have like standard evolution, survival of fittest, the environment around us determines which kinds of animals evolve in which ways and which ones survive, right? On the ecosystem. In our world, it is governance. Governance, the decisions of humans will actually decide the direction of these kinds of protocols. And I think this is kind of often forgotten, that blockchains are a product for humans, for us, right? And so we need to be able to have a way to influence and tell the blockchain, this is what we want you to provide to us as a society. On-chain governance is that process. We have the technology which allows us to upgrade the chain, and now an on-chain governance system which not only votes in the direction of the chain, but can enact those changes as well. It is not enough to have a token where you can vote, I would love for this blockchain to have this idea or this feature. Great, so you make the vote, and guess what? No one programs it. There could be a discrepancy between engineering or validators or other actors in the system, right? That just saying you want something is not enough to make it happen. That in our blockchain system, we have the ability to actually enact those changes from an on-chain governance system. We are able to actually make an upgrade from a vote, make a change from a vote. And this is a key part of putting power in the hands of voting dot holders or voting token holders, right? Other ecosystems, they might say, oh, we have a governance system here, we have some way to upgrade here, but if these two things are not connected, then they are not relevant for each other. They are exactly two separate systems. It is all a facade. And then the on-chain treasury. We hope that Polkadot will live for many years beyond the lifetime of all the original founders. Right now, Polkadot is very new. It feels, there are people who really carry and guide it to keep it evolving, right? But there'll be a time where, this will stop happening. That will stop happening, but the people who are guiding it today will not be around anymore, right? So we need to have a mechanism on the chain so that even after that time, the blockchain itself can keep itself running. If Parity, if the Blockchain Academy, all that disappeared tomorrow, could Polkadot continue to fund itself to keep it evolving, to keep it, engineers building on it? And the answer is yes. With the on-chain treasury, Polkadot has a mechanism to access funds which it can distribute to any human with an address to be able to continue to help it build, right? And we're starting to see even, application-specific forms of the treasury, things like the fellowship, things like proposals and governance, things like, these collectives. But the core type 1 decision is that Polkadot should have access to its own funds that it can distribute to help keep it alive and relevant, to keep it evolving. Incentivize others to build on it. And you have to remember also that our treasury in Polkadot is one that refills itself. So if you look, there are other blockchains which have foundations, and foundations got a very healthy sum of the tokens at the beginning. but they're not necessarily getting reoccurring payments from the blockchain to support the foundation. In fact, those foundations are often running out of money. What happens when there's no foundation left to pay for all these things? We have designed in our system a treasury which is constantly refilling itself so that it can support itself to grow, right? Type 1 decisions. It would be, imagine today, take any blockchain you can imagine that was made more than 6 years ago, and it said, we're going to change the protocol so that this foundation starts getting more money. That would be a huge drama, right? You need to build these things from the beginning, because if you try to add it afterwards, it's basically a change to the protocol, a change to the ideas itself. Type 1 decisions. Okay. So now I think it would be a good time for maybe a quick amount of questions, but now that you've seen the type 1 decisions of Polkadot, I want to walk to type 2 decisions. So, did you have a comment you want to say? Yeah. Can we get the microphone over here?
About the thing that block finality is separate from block consensus.
Block production.
Production and finality. You can argue that when you separate things, you can continue producing blocks without having finality.
Yes.
But from the end user perspective, if the block is not final, he's not sure if this block is valid, will be in the change. So in
Correct.
the end, for the user, what is the purpose of having a block that maybe is not a block?
That's a great question, and I will give you exactly this. That if you agree that there's a chain with instant finality and a chain with this kind of finality, and both have a finality issue, to the user, it's exactly the same thing. That both chains, like any chain, if it's not finalizing for 20 minutes, then every user on any chain, no matter what the system is, will not have knowledge of the transaction finalizing in 20 minutes. The difference is, though, if we can separate block production, then the blockchain itself doesn't halt, which means that we can actually interact with the blockchain, upgrade it, change the configuration, try to heal it without just it stalling and dying. So to the end user, there's nothing you can do about finalization issues. Finalization is finalization. But what we can do is, in a time of finalization issues, we can ensure that the blockchain is still interactable so that developers can actually maybe find a fix and push out a fix. That's the kind of idea I'm talking about. So it's actually not for the end user. The end user is waiting for finalization. But we're making the assumption finalization is a problem. How can we then optimize for resiliency? And that means giving developers a dead blockchain is worse than giving developers a block-producing blockchain. For example, I mean, I'm making up a scenario. Imagine for whatever reason there is a fork in the network, let's say Polkadot, and you have two separate blockchains being built and no finalization. You can imagine some kind of human coordination where we upgrade both halves of the network so that they come back together. I don't know, I'm kind of making things up, but like you can imagine if it didn't build blocks, it would be much harder. So does that answer your question? For the end user, finalization is absolutely the key thing, but we're assuming a finalization problem. Okay, can we bring the microphone to the back?
Hey, I have a question about scalability and sharding.
Okay.
From what I understand, each parachain produces a block and sends the block to the relay chain to be validated. And my question is, how do validators validate the block? Do they still have to execute the whole block?
That is a great question, which will be answered over the course of this section. So I think even today, by the end of the day today, you should have to answer that question. If you don't, then let's ask it again at the end of the day today. Okay? Do you agree? That should be, huh? Tomorrow. Okay, I lied.
Just following that question about the finality, so there is simulating a scenario where happened a problem. So the blockchain is still alive and developers can fix it. This needs, like, if someone or a group of developers, they find the bug and, hey, we need to fix this way, is it still needed to pass through a vote and everything agree and then update the runtime, right?
Yes, of course. Yeah, I mean, well, let's say this. As you've learned in the engineering tract, you have access to design whatever system you want. You could build a system where if finality isn't lagging, then the rules to access the blockchain is easier or something, right? But you can, whatever system you can imagine, you can build. What's important with the type 1 decisions is that you can design your own governance system. By the way, there are different forms of governance. There's governance of I am sudo, I have full access. That is a governance system. There's another one, it's like, there's 10 of my friends. We are the full access. That is a governance system. There is, all token holders have a vote. The important part of the type 1 decision is that we don't care which governance system you have, but it's the fact that you can put it on chain and can enact changes on your blockchain. But yes, whatever you can design, you can build it.
In the Polkadot case, who group is the pseudo?
The pseudo is 50% dot holders. So I think that's somewhere. Yes. 50% of the total dots in the system should be able to control the future of the system. So if 50% of the dots say, or 51%, say, we want to kill Polkadot, it will be done. Literally. There's nothing that anyone can do about it. Of course, you can make a new chain, you can fork it, all that kind of stuff, but in terms of that chain with that vote, it will be done. The dot holders are the decision makers.
Thank you.
Okay. Let's move forward to type 2 decisions, okay? We're following so far the ideas? So these are the core pieces, the decisions that are very, very difficult, if not impossible to make after the fact. But it gives us a foundation on which we can build a protocol and make specific decisions. So now I want to talk about those specific decisions which exist today, but may evolve and are evolving for tomorrow. And it can evolve because they're type 2 decisions. First was parachains. This is one that is happening in your very, at the very moment. That literally, as you go to sleep, there's someone else waking up thinking about the evolution of parachains. Now, parachains initially were designed to be these long-term application chains. Look like this, right? You have a parachain, and it's just building blocks on its application. Exactly, it's just going forward and moving, it's doing its thing. This is evolving. Because this was designed using execution cores, we can now envision and think about designing and building a system where parachains, or whatever the applications running on Polkadot, look more like this, where execution cores don't have to run just one blockchain, can run multiple blockchains depending on the resources available to that execution core, right? You can imagine a core has some memory, some execution, some storage, whatever. If you don't use all of it, we can give more of it to another team or another application. You can have 2 small applications running on one core. This whole flexibility comes from the decision of making execution cores. And we are working on engineering things, not by changing the type 1 decisions, but creating other abstractions for how to access these cores in things you've been hearing like core time, core play, core jam, whatever the different cores are. So the future of the protocol will have even more exotic core scheduling, even more agile core usage, all because type 1 decisions around parachains is actually execution cores. In many ways, it's all kind of like marketing and branding, right? But in the code, this is what exists, and we can build it. Now, we talked about the need for cross-chain messaging and a protocol for that in the Polkadot level. And we have that. That's called XCMP, the cross-chain messaging protocol, or cross-chain messaging protocol. But the actual details of that protocol is not defined in Polkadot. It is just the ability to move bytes from parachain to parachain in a secure way. What we have provided to the ecosystem, along with XCMP, which is very much a type 1 decision, is a type 2 decision, which is called XCM. This is the cross-consensus message format, and will be the topic of the last section in this academy. I want to clarify that XCM is just a flavor or decision coming from Parity. That if you want to build your own messaging format, you could do it, and you could use XCMP for that. It just makes sense, though, that when we're building these kinds of systems, someone needs to come out there and say, here is the first standard, here's the general standard, start using this, so that these teams can actually coordinate with each other. But it is not the goal of Polkadot to define that XCM is the only way to communicate, or that this current iteration of XCM is the right way to iterate. We already are on XCM v3. The reason we can iterate so quickly on XCM is because we made decisions at XCMP level to keep things generic and have that be the type 1 decision. So the actual message format will change all the time, and I will hope to see that other message formats will start to come up from parachain teams with different needs, right? But this is a type 2 decision. We can iterate on it because we provide a general messaging protocol. Nominated proof of stake. Now, there's a lot of words on this slide. Let me do this. One of the key decisions, type 1 decisions, is to provide shared security to the network, right? So you've heard of proof of stake, and I'm sure that if you go around to someone in the layman, they'll say, oh yeah, these are all proof of stake chains. But what you should know is that proof of stake has very little meaning by itself. That the implementation of proof of stake is very important to say what kind of proof of stake system it is. Even between two delegated proof-of-stake systems, it could be totally different. Do they support slashing? Do they support what kind of rewards? How exactly do they nominate? Like, if you look at Ethereum, Ethereum has proof-of-stake, but each node is a user with 32 ETH that makes a node, whatever. And if I have many, I make many nodes. On something like Cosmos, you have the validators, but then you just have simple delegation. Users vote for just one user. In order to maintain the most secure network and provide the best shared security across our ecosystem, we decided to build this nominated proof-of-stake system, which is inherently more complex. A nominated proof-of-stake system, I mean, if you ask the engineers here, I mean, there's like just one, I think, who built a DPoS system, it is not crazy difficult to do. But this is actually what most blockchains rely on. We actually spent much more effort, much more research to build this nominated proof-of-stake system in order to provide more security to our network. So our NPOS system over a DPoS system is better able to allocate stake. We see 25% more stake behind the elected set in our NPOS system compared to DPoS. Now the truth is, our NPOS system is not as scalable as a DPoS system. That's hard maybe for some people to hear. Like I'm saying, our system is not as scalable. But the goal is not to scale arbitrarily. The goal is to scale with resilience. That if we can make a less scalable system in terms of numbers, but a more resilient system in terms of having our backing stake back our validators, that is the better choice for our decisions, for our philosophies, for our alignment, right? So our NPOS system provides economic incentives to distribute funds evenly across validators, therefore giving less number of validators control over the network and increasing our Nakamoto coefficient. So basically, you can believe that if you have 100 validators on Polkadot and 100 validators on another DPoS system, that's a delegated proof-of-stake system, that we will provide more security using the 100 validators than they will with theirs, because we have more complicated algorithm to ensure that the elected stake, there's more of it backing them, and it's more evenly distributed. Right? And this protocol itself is also evolving. There are things like nomination pools that we're working on. We're obviously always iterating on the NPOS protocol itself to make it more efficient, but we have decided something that is, from a computational standpoint, more complex in order to provide the goals and philosophies of what we want. Okay? And then sassafras. So we talked about the hybrid consensus system, the separation. Right now we have Babe and Grandpa. Even today, things like Grandpa are evolving. We are looking to build things like, Babe is evolving. We're looking to build things like sassafras, which has, which evolves and tries to act as a better constant time block production system than Babe. So the separation of the two is something that's in the protocol. But how one individual protocol works, we are continuing to evolve. So sassafras is this semi-anonymous sortion of staked assignees. I mean, this is a day of engineers spending trying to figure out how they can make an acronym, right? But the idea here is basically to take advantage of the newer technologies like ZK snarks and ring VRFs to provide even better guarantees to our system, right? So as technology and research evolves, we have a system which can evolve with it, right? That's the main idea here. OpenGov. We talked about on-chain governance being a key type 1 decision, but the rules of that governance have been changing over time. We had in the past, when Polkadot launched, Sudo. We then upgraded Sudo. Sudo upgraded itself to a semi-open governance system where basically there was token holders and there was a council helping with treasury funds. And more recently, we moved to a fully open governance system where basically token holders are the only ones with say on what happens. Now, if you've been following Polkadot, OpenGov is a very fun space. It's very drama-full, right? But in fact, it is an important part of ensuring that this protocol is fully resilient and fully decentralized from any central actors. And I want to say that, OpenGov is probably not perfect today. It doesn't have to be. It is a type 2 decision. We can make a decision on building OpenGov, launch it, and if we need to, we can iterate and upgrade it. I expect there to be changes to OpenGov in the future. Again, OpenGov, the protocol or the exact palette, is not the type 1 decision. The type 1 decision is that there is governance at all on the blockchain that decides the future of our blockchain. Treasury and fellowship. So as I mentioned, the type 1 decision of Polkadot is to have a treasury, to have a source of funds to actually distribute to users. The mechanism for distributing that funds is a palette, right? It's a set of palettes like to have treasury, fellowship, bounties, etc. And these things are also evolving over time. they can evolve. There's a mechanism, there's a pot available. How we distribute the funds, that can change. So again, these are all type 2 decisions. When you say, I know the Polkadot treasury, like it has these features, the wrong thing to think in your mind is this is Polkadot. That is not Polkadot. That is a type 2 decision of Polkadot. The type 1 decision is that Polkadot at all has a treasury. Right? So I want you, again, the people in this academy to envision the future using the type 1 decisions that they want to build onto Polkadot. You can influence and mold Polkadot in these ways. And there's many more. Again, what I'm trying to really say here is that Polkadot is designed to evolve and make type 2 decision making fast and easy. It is an invention machine, right? So if you can really believe that, then I think you can get an idea for what Polkadot is. So what is Polkadot? These are the words of Robert Habermeyer, but Polkadot is a scalable, heterogeneous, sharded multi-chain network. It is a permissionless and ubiquitous computer. It is a decentralized open source community, and it is a digital native sovereign network. Okay, any questions?
So there was a question regarding making changes in code. So through 50% of holders of DOT, right? And my question is, if we want to modify the code base, there's supposed to be engineers, right? And the community is not all, like, community members, not all engineers. So how you get these 50% of votes?
Right. So again, this is where you cannot program social mechanics. You can only program economic incentives, right? This is a big thing here. I can program economic incentives, how I can move and use DOT token to incentivize certain behaviors. You cannot program the behaviors themselves, right? So what we have in Polkadot is a treasury. We have in Polkadot a fellowship, right? Which is a bunch of technical programmers. And we know that, and the fellowship knows, and it's truth, that the only way that it gets funded is that if the token holders vote to fund them, right? So in the situation where the fellowship does not build the features or needs that the DOT holders want, DOT holders will not fund them. They will find a new party. They will find a new people who will accept their money. And then those users will build the technology they need. And then those things will get pushed to the blockchain, will get upgraded, will get voted on, etc. So really, as a DOT holder, you are in charge of deciding the future of Polkadot. You may not be able to yourself program what you want, but you can describe the features, describe the mechanics that you want, and then use your DOT token to vote on how Polkadot will spend its DOT token to fund those creations. So again, we have the mechanisms here for you to influence this thing. We cannot, of course, build programmers into the protocol, right?
Okay. There's also seems to be a very, very small misunderstanding. 51% can force changes, but it doesn't need to be 50% support to enact any changes.
Right.
So if there is some change and only a small minority of the network agrees with that change, but no one from the network disagrees, the change can pass even with support less than 50%. So in that case, all the developers might have less than 50% power, but they can still control and push the changes that are needed.
Yeah, and we'll cover this later in a slide called ecosystem and economy. But there basically are these curves which determine with the tokens that showed up to vote how we make decisions, right? But the idea is that with 51% of tokens, something will always go through. Like that is the final decision if you have 51%. But you don't necessarily need all of it based on the curves. But yeah, we'll talk about that later. But again, all of those decisions, even that decision, is a type 2 decision, right? It's a thing that we can adjust and change.
When I see the history of Polkadot, it started from like a centralized decision. Like imagine in the beginning, only could give some decisions and evolve, and then became a council with like more people, but yet a little bit more centralized. And now it's like open everybody. Okay, so it changed from centralized from Gav to the council because Gav wanted. So we have like for his will, it became a council, and the council allowed it to be to be open to everyone. Because if this council just didn't want it to give up of power, it wouldn't be done, right? Imagine the situation when because you were talking about the trade-offs between democracy and dictatorship, because in dictatorship you can take decisions faster, but it's only 1 or 2 persons taking decisions. I'm talking about this because there's no right, I don't think there is a right or wrong. You talked about the craziness that it is right now, that is open gov, and now people start fighting with each other, which is the best view or not. My question is, what if this democracy people, they decide that the best way to do governance is to give power to a dictator, because like I believe that it's better to give it back to someone, and this someone doesn't give back to people. So what's going to happen in the end?
I think this all goes back to philosophy, right? You're describing a very specific scenario which can happen. I'm saying that Polkadot, the technology can allow that to happen. But I would ask you, is the thing you described in alignment with the philosophies of Polkadot? I would say what you're describing is some technology which is not Polkadot that I acknowledge as Polkadot. Polkadot is a set of philosophies, less trust, more truth. So a move back from a decentralized party to a dictatorship is a step back from the philosophy of Polkadot. Maybe the world calls that thing Polkadot. Names are just a simplification tool for us to express ideas. Polkadot to me are these 3 ideals, and that is not Polkadot. But it's, again, the technology allows for it. So why, it could be whatever it wants. Does that make sense? So again, if you believe in this philosophy, I think you would know that is not the direction that a protocol with this philosophy would go.
And what happens if the validators do not follow like the rules? Because you said
the founders, right? What happens if Gav didn't ever give up the...
No, I mean the nodes that are running the blockchain, if they decide to go against the governance is made by the votes.
Right.
But what if the machines that are running the network decide to collude and do something different from that?
There's many answers to that question. First is our system is much more resilient to that kind of problem because unlike many other other blockchains where you have to upgrade the client every time you want to upgrade the logic, our logic is built into the state transition function of the blockchain itself. So a blockchain with an upgrade in it, if they fork it, it is not the same blockchain. Our blockchain actually has built into it. This is the logic of the blockchain. If you choose not to run it, you're running a different blockchain. And forking chains is absolutely a part of the world. Like that's a social thing beyond the blockchain. But at that point, those block producers aren't building the same blockchain. What will actually happen is on our blockchain, they'll start getting slashed because they're not producing blocks or doing their job, right? They'll be losing their tokens. And any one of you can go permissionlessly spin up a blockchain, make yourself nominate, choose to be a validator, get nominations, and build a blockchain forward. These systems are designed to be completely permissionless. Decisions of many of users are allowed to happen, but we are also very easily able to counter those things by just following the protocol. So those users will get slashed, new users will come in, they'll get rewarded, the system will go on.
Why does sassafras is in type 2 decisions and not in type 1 as grandpa and babe?
Well, I mean, think of this. Do you agree that we are using Babe today and we'll be moving to Sassafras, we're working on and building Sassafras tomorrow? Like, the fact that we can do that and do it, not in the most crazy ways, evidence it's a type 2 decision. It would be much harder, what I'm trying to say, is that to build a blockchain where we had a single finality system and then try to upgrade the block production part of it, separate from the finality part, right? That would be much harder. But because from the beginning of Polkadot, we've designed this 2-part system, and we have lots of things, for example, information in our block headers, which support this system, that we are able to actually upgrade the part more easily. I mean, you agree Sassafras is being developed, so the fact that we're able to iterate on it and not change the whole protocol is evidence that's a type 2 decision.
So when it's the developer descent is going to be type 1 or something related with Polkadot 2.0?
2.0? No, what I'm mentioning here also is that, in fact, almost all of Polkadot 2.0, the part that I understand, this execution core stuff, is all just layers on top of what already exists. That we built when we built Polkadot, the idea of shared security on execution cores. So how we split up the cores, that this diagram is basically the layer 2 decision thing that we're here, that we're creating. So that we had this execution core already existing. We already have secured it. That was a type 1 decision. We productized it as a parachain like this. That was a type 2 decision. And now we're productizing it into something like this. And this is harder to program. It is the natural evolution of this idea. And we can do it because of our type 1 decisions.
Okay, got it.
If you have a question back there, I think you need to probably come up more to the middle. Let's get the mic then, over here, yeah.
I have a mic, yeah. So I have two small questions. One of them, first of all, is the block production. For example, you mentioned that when some blockchains got halted because of the finality one not happening or instant finality claims. So in case of Polkadot, what will happen like when the block production is still going on, right? But the finality is not there. And to fix it, a developer pushed out some code to the client to fix the logic or try to fix it. In that case, the voting will happen outside the block production. Like these things happen outside the blocks.
Usually you need to do social engineering there too. Yeah. So usually you need to involve client upgrades, talking to validators, having them coordinate together to up things. These are all kind of unavoidable necessities.
No, even in Polkadot?
Even in Polkadot, we've had it before where in Kusama specifically, like there have been problems. We've needed to, like again, we could the forkless upgrade feature only touches the runtime aspect.
Yeah.
There's still a client, and that client is very heavily involved in a lot of the networking and consensus parts. So if there's a bug at that level, you still need to coordinate with other people. But the idea is that, instead of every single upgrade having to go through that pathway, we provided a streamlined pathway for the runtime.
Like in this, my question was because like Babe and these consensus things are part of the runtime.
No, there's parts of it in the runtime, but the majority of it is actually in the client.
Oh.
So the runtime stores some like relevant data. For example, like who are the current block authors? What is the current block era, epoch, the basic stuff.
Okay.
But all of the actual stuff is happening outside of the runtime because it's all happening asynchronously and happening in parallel. There's like tons and tons of threads running that are doing these things. It can't happen in the runtime.
Okay. And the second question was, you mentioned during the talk that you would be you would love to see more messaging protocols like XCM into the market. But in that case, like as a Polkadot, if we think of as the community, then there's multiple parachains. If there are multiple people talking in like different languages, right? If it is a community, if it's a country, I know there's even in India also like there's countries and people talk in different languages, but it creates barrier a little bit. So why would you would promote this if it is not in first place? That's my question. Right?
I think it's all about like how far we push the idea. I think that probably an ecosystem with 3 languages is probably better than 1 language. Probably because 1 language has a hard time being optimized for all the needs. It's just like an application-specific blockchain. I think an ecosystem with 1,000 languages is much worse than one with 1 language, right? Because then 1,000 languages, you have basically no support at all, right?
But
it's somewhere in between.
You would want to migrate to the better one, or you would want to stay like both parallelly?
I think that's the thing, though. Like it's decision of the community. This is not the whole point is that this is not the type 1 decision. That the community can decide that. I think that if I can describe to you different scenarios here, where if you force all of the ideas to go through XCM, ideas will move much slower. If someone else can tinker on the side, independent of other like RFCs and other processes, show something is good and then build it, that's great. And we've seen that this is a pathway towards, kind of like free markets are kind of a good pathway to finding great ideas. So I think that you can think of XCMP as a free market for people to build messaging protocols, and standards will come as community seem to align with what's good.
Lastly, in this, so before the slide, I guess you mentioned that this core time upgrade that is on the planning and is trying to rolled out.
Yeah.
This is a type 2 decision. That means like, is it something that you will try to figure out on the Polkadot network that is it making sense or are people getting interested? If things doesn't feel right, it can also be turned back by the
turned back or continue to be evolved on, right? Yeah, like we have right now these execution cores. They're very generalized. Like they just run WAS and blobs, and we'll show this more throughout the week. How exactly we package it, let people access it, all that stuff is that is the application layer, which is the type 2. So I think we can continue to evolve on it, go back on it, whatever we want on it, right? That the whole point is that at that layer above it, it's fast, iterative invention machine.
Got it. Thanks.
Okay.
Yeah, thank you. So about light client, if I run a node, I help decentralization. Yes, but is it the same? So how that works, helping decentralization with the light clients?
So yeah, so I think that light clients do not inherently make your network more decentralized. Now, I believe there are some protocols like Celestia, which are taking advantage of light clients to do something to help with their decentralization, but that's not the default thing. In general, a light client is actually like a leech of the network. That your phone is trying to send a transaction. For you to send a transaction, you need to know how much money you have. For you to know how much money you have, you need to reference the blockchain. There's two ways you can do that. One is you trust like a centralized RP. There's I guess three levels. One, you trust a centralized actor like Infura. They provide an RPC. Other, you talk directly to a node, right?
Yeah.
Or the other one, you talk directly to a node, and the node can provide you a proof, a Merkle proof, of here is the root hash, which you've been syncing on your light client, and then here's the full data, and now you can see your balance matches into this root hash. Now you know how much money you have. So in this context, light clients are not inherently making it's not adding to decentralization of like the core protocol. It is just a tool allowing you to access the blockchain in a decentralized way.
To do not trust a centralized
Exactly.
node. Yeah,
but I guess there are probably other
itself.
Exactly. There are other things, I guess, like Celestia I think is probably doing cool stuff with like light clients and having them actually contribute back to the network. But that's not in my mind the default idea of a light client.
But in Polkadot there are plans to do light clients that help decentralization?
I don't think so. I mean, can you describe to me how can a light client help me secure parachains? Like the whole point of it being a light client is that it's light. It's like your phone is not going to be a useful part of the Polkadot.
It could be used for validation of the transaction somehow.
So unfortunately, again, this is things when we learn about shared security and stuff like that. I think some of these high-level ideas will break down. When we run a blockchain, blockchains need to have a standard hardware, right? Like, if I'm running if this guy's building blocks on his MacBook Air, your Raspberry Pi is going to keep up. It's not going to be able to go at the same speed. So your Raspberry Pi can't actually contribute back in a helpful way because it's going to be spending more time just trying to validate all the other work before it can actually even create a piece of code. And when it creates a piece of code, it'll be super inefficient. Like imagine a blockchain run on Raspberry Pis. This is going to be a very slow blockchain, right? So there's all about a trade-off between, having hardware which is actually useful to be used, right? But also accessible by all, right? Not just like having a supercomputer. So in this context, your mobile phone, there are probably some things it can do to provide back to it, but it's not going to be part of the parachain validation process. It's just, by inherently is a weak computer, right? Weak computers aren't going to be able to keep up with the network. So again, I think this is where, and I don't blame the confusion. I think that what I would hope for is that by the end of this Polkadot lecture, you have a more concrete understanding of the roles of these different nodes and how exactly a validator node in Polkadot does its job to help the network. And then you will realize why a mobile phone would not be good at that.
Yeah, no, I got it.
Okay,
I know there are some blockchain that has a light client does validation for some degrees.
That's kind of so I don't know enough about all the protocols.
Yeah.
But that fires by bullshit alarms.
Mutual does this.
But that fires. Just think about it. It fires the bullshit alarms because are you saying that a blockchain, let's say it has 1,000 TPS. I'm just making up a number, right? 1,000 TPS is defined because they pick some hardware which can run the network, right? Like if I picked a more powerful computer, I could increase my TPS just by the simple laws of thermodynamics and the worlds, right? So if that network where all the nodes, the big nodes, crashed, and that's all run by mobile phones, it will still have 1,000 TPS? Or it will be resilient in all the ways, like all the assumptions will stay the same? No, right? Like it's inherently something will be weaker. So when you're saying this phone is helping secure that network or whatever, but you can't actually run the network on all phones, it's like it's just a facade. It's like some kind of bullshit marketing statement in my eyes.
Could be.
So this is, like, don't be caught by the marketers. Like marketers are going to tell you all these things. They're going to tell you, we have instant finality. Oh my God. And what I want you to realize is there are decisions and trade-offs.
There are some peer-reviewed documents that say this, but I'm not the more entitled person to know.
Well, that's what I was saying. So
there are solutions.
When you're looking at other protocols, you need to not take the words at face value, the decisions. We all live in the same environment. We are all making decisions and trade-offs. I think what I'm trying to do in this presentation is present our decisions. I can't speak on other people's.
Okay, thank you.
And also in Polkadot, we are getting into the weeds here, but the type 2 decision is we have like 300 active validators. So, and those have very specific hardware requirements. And if some of them would have like supercomputers, some of them would have phones, and because of the way we do sharding, then some of the shards would be significantly disadvantaged.
Exactly.
And it would be an issue based on the current architecture, so we cannot really allow that.
Yeah, but just last comment. But even in Bitcoin, there is the same concept. You can run a miner with an ASICs and a node that it could be on your laptop.
Actually, no, but
it's not about.
It's totally different. It's
yeah, I got it.
No,
but
sorry,
the idea of the light client.
Pause for a second.
Yeah.
It's totally different because Bitcoin isn't providing a shared security platform for a bunch of parallelized chains. It is one chain. So in that context, right, you running one chain, it's like it's a completely different architecture and design. So that mechanism of you running your phone and mining, and let's be honest, you're mining something on your phone, you're just burning your phone's battery. You're never going to make a block
Not for mining, for decentralization. You can run a node to decentralize the network without mining.
But so in this case, running a node on your phone is decentralizing in some aspect, in the sense that you now have another copy of the Bitcoin database. But it is not providing shared security. It is not like, so this is another aspect where again, this is a different protocol. Polkadot is not just a blockchain, it is actually providing back to other blockchains some level of security and execution. Bitcoin isn't doing that to other blockchains. So yes, you can run a Polkadot node, not a validator node, a syncing node. You can have your own database copy of Polkadot on any hardware you want. Right? It could be a Raspberry Pi. Actually, we have Raspberry Pi support for running a node. It is not a validator node. It is not a node providing security. It is just backing up the network. It's a totally different concept here. So you really need to separate in your mind a validator node doing security and actually validating the network and creating new blocks, and then just a syncing node, which is just syncing. And your syncing node could be lagging behind many, many blocks from the main blockchain, depending on its execution abilities.
Thank you.
Okay. Anyway, a lot of these concepts, again, I think that it's like it's all of these ideas. It's easy to mistake some of these things, but once you have a concrete understanding of what the actual players are and what they do, then these things become more concrete. So I would hope by the end of this Polkadot section that you will have a more concrete feeling of what exactly different operators are. Anyway, I think that seems like at the end. So I want to say this. In Introduction to Polkadot, there are many versions of it. You'll even hear more about specifically Polkadot right after this. But I hope that you understand this perspective of a philosophy, a set of goals, decisions you make at type 1, type 2 level, and that all comes together to create the protocol we're working on today, right? So when you think about what is Polkadot, do not think about, oh, Polkadot does this, you call this function, do that. Polkadot is very much a philosophy, and it's constantly evolving. And I think we've built not only an invention machine, but one that evolves very quickly, and because of that is very resilient to the future. Okay, so let's take a break, and then we'll go to the next lecture, right? Great. Thank you.